Okay, so now let's do a Kirchhoff's laws problem. So Kirchhoff's law problems always take a while to do, but it's basic algebra and it's easy to make mistakes because there's so many steps that you have to take. So let's walk through. And this problem's nicely laid out. It already tells us what all our currents are and what our loops are. So it's a bit easier for us to look at the picture and decide what to do. So how do you start off? Well, you always start off a Kirchhoff's law problem by doing the Kirchhoff's current law, and I want to do it at a point where the currents are coming together. So I can see I've got I1 is coming up over the top, and then it splits up into I2 and I3 at junction A. So let's do Kirchhoff's current law. I'm going to abbreviate it KCL at point A. All right, so what do I have? Kirchhoff's current law is current in equals current out. So in, I've got I1, out, I've got I2 plus I3. So there I've got I1 equals I2 plus I3. And let me just put a circle around that one. We're going to call that equation 1. All right, so we need 3 equations because we've got 3 currents. So we're going to have to get 2 more equations. And we're going to do those 2 equations by picking 2 loops. So there's 3 possible loops we could do. One is the loop 1 shown here, just going around the left-hand loop. Here they took loop 2 is going around the whole outside. And the third loop we could do would be to go around the right-hand loop. And it doesn't matter which 2 you pick. The algebra should be basically the same steps and you should get the same answer. All right, so let's do loop 1 to get equation 2. So loop 1, we're going to go around loop 1. Let me start off at the battery. So I'm going to start off, let me do it in blue here. So I'm going to start off at this point that I'm drawing with an X in the bottom left-hand corner. And go up through the battery, through that 3.9 ohm resistor, which has a 1 beside it, so we'll call that R1. Then I'm going to go down from point A through resistor 3, and then back through resistor 4 to the point that I started with. So I know that if I add up the sum of all the voltages around there, I should get 0. All right, so starting off at point X, I'm going to go up through that battery. I'm going to go from the negative to the positive. So the rule is that that's a plus V. So I'm going to do plus 12 volts. Then I have resistor 1. I'm going through resistor 1. So I'm going around the loop in the direction that's shown here, clockwise. So I'm going through that resistor in the same direction that I1 is. So that is going to be a negative voltage. So I do minus I1 times R1. I get to point A, and at point A, that I1 splits up. I'm going down that center arm in the same direction as the current. This time the current is I3. So it's going to be minus I3 times R3 because, again, I'm going in the same direction as the current. All right, I'm going to get down to that bottom junction. And now my current, now I have I3 coming down the center arm. I2 is coming back from the right-hand arm. They're going to combine together to give me back my original current. So I'm going through resistor 4 in the same direction as I1. So again, that's negative. So minus I1 R4. And that has to be equal to 0. So I can go ahead and put in all the numbers that I have. I know the resistances. I don't know the currents. So I've got minus I1, I don't know. R1 is 3.9. So let me just write that as minus 3.9 times R1. Sorry, times I1. Minus R3, 1.2 times I3. And R4 is 9.8 minus 9.8 times I1 is equal to 0. And let me do one more step. I can combine this term and this term. Both have I1 in it. So I can combine those two together. So I get 12 volts minus 3.9 plus 9.8 is 13.7. I1 minus 1.2 I3 equals 0. So that's as much simplification as I can do. So let me draw a circle around it. There's my equation 2. All right, so we've got 2 out of 3 equations. Let me pull this up a bit. Now I'm going to do the same thing for loop 2. And loop 2, we're going to go around the whole outside edge. And let me start at the same x. So I'm going to start, the first 2 steps are going to be the same because I'm going to go through that battery. I'm going to go through that resistor. So it's going to start off the same. So I'm going to get, let me do it in green so you can see I'm doing a different equation. So I've got 12 volts minus I1 R1 because I'm going through it in the same direction. Now from point A, I'm going to continue going towards the right. And so I'm going through resistor 2 in the same direction as current 2. So that's going to be a negative again. Minus I2 times R2. Then I'm going to go down from resistor 2. I'm going to go down that right-hand arm through that battery. And I'm going to go through that battery from the plus to the minus. So if I go towards the minus, it's in minus V. So I'm going to be minus 9 volts. Okay, so now I've gotten all the way down to point B. There's nothing in this section, so there's no voltage drop. And then I'm going to go back through resistor 4 with current 1. So I'm going to do minus I1 R4, since I'm going the same direction as the current. And I'm back where I started, so I set that equal to 0. All right, so let's now plug in our numbers for the resistances. So minus 3.9 is R1, I1. Minus 6.7 is R2 times I2. Minus 9 volts minus 9.8 times I1 equals 0. And now let's simplify that a bit. So if I simplify it, I've got, let's see, I can combine the 12 minus 9 to give me 3 volts. The 3.9 and 9.8 I1, where I can do the same thing I did for equation 2. Minus 13.7 I1 minus 6.7 I2 equals 0. So now that's my third equation. So I've got equation 1, which is up here. Let me just slide that over a bit so you can see it. So I've got I1 equals I2 plus I3. That's my equation 1. Got equation 2 and I got equation 3. So I've got 3 equations and 3 unknowns, so I should be able to solve it. So now from this point, it's just algebra. So let me take, first of all, I'm going to take my equation 1. So the next step you always do is you take the Kirchhoff's current law equation and you plug it into one of the equations. So what I'm going to do is I'm going to substitute, in this case, let me substitute 1 into equation 2. Okay, so I'm going to put 1 into 2. So what's that going to do? I'm going to take my I1, and everywhere I'm going to take my I1, I'm going to replace it with I2 plus I3. Okay, so I've got 12. Make a little bit more room. I'll do it up a little bit higher. So I'm going to do that over here. So I've got 12 volts minus 13.7 I1. Instead of I1, I'm going to put that as I2 plus I3. Minus 1.2 I3 equals 0. And I'm going to simplify that. So I got 12 volts minus 13.7 I2. I'm going to distribute those terms. Minus 13.7 I3 minus 1.2 I3 equals 0. And then I'm going to combine those two I3 terms. So 12 volts minus 13.7 I2 minus 13.7 and 1.2. So it's going to be minus 14.9 I3 equals 0. Okay, so there's a new equation. I'm going to refer to all these equations as we simplify. So let me call that equation 2a. All right, so now I'm going to do the same thing with equation 3. So I'm going to put equation 1 into equation 3. So I'm going to take 3 volts minus 13.7 I1, and instead of I1, I'm going to put I2 plus I3. So basically what we're doing here is we're taking equations that were in terms of 3 different currents, and we're just writing them in terms of 2 different currents. Right, so minus 6.7 I2 equals 0. Again, distribute that 13.7. And continue writing. Next step, simplify. So I can combine, I've got two terms here that have I2, combine those two, so 3 volts minus 20.4 I2 minus 13.7 I3 equals 0. Okay, and that's my new version of equation 3. So let's call that 3a. All right, so now I've got two equations with two unknowns, and now I've got to do a little bit more math to simplify it. All right, so how do I do that? Well, there's two ways I could do it. All right, so one way I could rearrange it and solve for one in terms of the other. The other is I can add the two equations and make them equal to each other. So why don't let's see. I'm going to write those two equations down. So I'm going to scroll up here and rewrite them so we have enough room to see them one underneath each other. So I've got 12 volts minus 13.7 I2 minus 14.9 I3 equals 0. That's equation 2a. And the other is 3 volts minus 20.4 I2 minus 13.7 I3 equals 0. And that's my equation 3a. Okay, so what's different ways to do this? One way I could do this is to rearrange one of them and get I2 in terms of I3. The other way would be to multiply, like you're solving simultaneous equations, is I could say, okay, well, if I multiply equation 3a by the ratio of those two numbers, the I3 term will cancel out. Which way should I do it? Let me do it. I think the way students find the most obvious is let's rearrange one of the equations to give me the other. All right, and if you've taken linear algebra, you know you can solve this using determinants and matrices, but we won't do that here because we're not going to assume that you know how to do it. All right, so let's take this one, let's rearrange it. I'm going to get I3 in terms of I2. So I'm going to take the term with I3 over to the other side. So I've got 12 volts minus 13.7 I2. And I'm going to add the 14.9 I3 to both sides. So I get that. So I3 is equal to 12 volts minus 13.7 I2 over 14.9 I3. Right, so if you look at the notes that I have posted online, I solved it doing it the other way. And so this way you can see me doing it this way. All right, so now I've got to, don't want to divide by I3, just divide by 14.9. So now I've got to take this and I'm going to substitute it in. So I rearrange, let me write this down here. So I rearrange 2a, and now I'm going to substitute this into 3a. So everywhere I had I3, I'm going to put this instead. All right, so now let me see. So I'm going to rewrite 3a. So I've got 3 volts minus 20.4 times I2 minus 13.7. And instead of that I3, I'm going to write this down, 12 volts minus 13.7 I2 over 14.9. Okay, so now I'm going to have to do some math and some distributing. Oops, sorry, and that's equal to 0. So now you can see the only unknown I have in this equation is I2, so I can solve it. So let me bring up the calculator so you can see what I'm doing. Okay, let me move it out of the way so it's not on top of the equations. All right, so I'm going to write this. So let me do some simplification. So I got 3 volts minus 20.4 I2. All right, so now I'm going to take this, I can take that 14.9 outside. So 13.7 over 14.9 times 12 volts minus 13.7 I2. Okay, so let me take the calculator first and figure out what's 13.7 over 14.9. So 13.7 divided by 14.9 is 0.9195. Let me keep 3 sig figs. So 3 volts minus 20.4 I2 minus 0.9195 times 12 volts minus 13.7 I2. Okay, equals 0. Gotta put my equals 0 every time. All right, so now I'm going to take this 0.9195, I'm going to distribute it in there. So I'm going to multiply by 12, and I'm going to multiply by 13.7. All right, so first let's do it times 12. I get 11.03. So 3 volts minus 20.4 I2 minus 11.03. And then I'm going to take that minus 0.9195 times minus 13.7. Get my calculator back. So minus 0.91, whoops, 0.9195 minus times 13.7 minus equals plus, oops, it went away too fast, 12.597, so 12.60 times I2 equals 0. Okay, so let me see, I'm going to combine my voltage terms. So I've got 3 minus 11.03, so that's minus 8.03. I'm going to combine my two I2 terms, so I've got minus 20.4 plus 12.6. And I should be able to do that in my head, but let's do it on the calculator, make sure I get it right. So I got 20.4 and 12.6. So I've got minus 7.8 I2 equals 0. All right, so now that looks like something I can solve. So I2, let's bring one term over to the other side. So 8.03 is equal to minus 7.8 I2. So I2 is equal to 8.03 over minus 7.8. So I get minus 1.03 approximately amps. All right, so why does it come up as a negative current? That negative means when we drew the picture, we drew the arrow the wrong way. Okay, so we drew the arrow wrong, and so that means we guessed which direction the current was going wrong, but that doesn't matter. So if I go back up to my picture, so that current arrow that I drew up at the top, it should have been going that way, but it doesn't matter. All right, so as long as I keep my sign correct, then all my equations should work out correctly. All right, so what do we do next? Now we've got I2, we need to find I3 and I1. Right, so I've got I2 now, so I can take my I2 and I can plug it back in to that equation I had for I3. All right, so I3 is equal to 12 volts minus 13.7 times I2 over 14.9. And if I put my numbers in there, I get 1.751 amps. Okay guys, so now we're in the last step of the marathon. So we've got I1, so we've got I1 to find, we've found I2 and I3. So now we can go back to my equation 1. Equation 1 was I1 is equal to I2 plus I3. So now I can just take those numbers I found and plug them in. So I2 minus 1.03 plus I3 1.751, and I get my I1 is 0.723 amps. All right, so now I've got all my currents. The last thing it asked us to do was to find the voltages in each one. So to do that, we can just use Ohm's law. So V1 equals I1 R1, V2 equals I2 R2, V3, we have 4 resistors, so we're going to do that. V3 has a current of I3 going through it, and V4, if you look at the picture, R4 had a current of I1 going through it. Okay, so we're just going to put in our numbers for the current. So 0.723 times R1, which was 3.9, I get a voltage of 2.82 volts. My current 2 minus 1.03 times 6.7 ohms. So I've got negative 6.9 volts across that one. And again, the magnitude, if you're asked for the magnitude of the voltage drop, it's 6.9 volts. You would just take the absolute value. I3 is 1.751 and R3 was 1.2 ohms. So I get 2.10 volts. And finally, go back, I1 times R4 is 7.09 volts. Okay, so it's a long process, but it always starts off the same way. Use Kirchhoff's current law at a junction to give you equation 1. Then use the number of loops that you have to do to get equations 2 and 3 to solve for current 2 and current 3. And then start substituting in. So you take your current law, substitute into equation 2 and 3, simplify it down, and then just keep plugging away with the algebra, and hopefully you'll eventually get the correct number.